In this video, we're going to review EnVision, creating data for a vertical panel saw, as well as a HolzHer CNC machine. So the first thing we're going to do is select a product or a template that we're going to order. And everything here is unit parametrics. So we're going to change any of the dimensions or attributes of the product that we've specified in the template that we've configured. Now what we can see below is in the details pane, the bill of materials, the hop files, the images of the components are all created dynamically on the fly. So we can see that each of those components there has a hop file and they're each uniquely named. So the concept here is that we use a hop file one time, and then once we're complete with it, we throw it away. Right? So the goal here is that every time we order a product, the bill of materials and machining always reflects the template, right? So any changes we do today will be incorporated into the programming on the orders that we create tomorrow. Now at this point, we're going to save the order. The optimization is going to go through for the vertical panel saw. Now we will open up MVLabeler, and this would be add a PC at the vertical panel saw. And we'll see that we can select the job NG858 and then select the 3 different sheets of material that were optimized for this specific order. As we click on each of the components in the sheet, a label would be printed for that specific component. Once we've gone through and selected all of the components and cut them and labeled them, we can come up to the top of the screen and we can select the checkbox, which will allow us to say that this sheet is completed, right? So the operator just simply checks off and says, yes, I've completed this, and we'll see that checkbox get placed next to the material on the sheet. Now we can go ahead and open up some of the labels. So these are just an example of a label that could be defined. They're completely user definable, so you can add logos, different portions of information that you require for the jobs. You might have a room or a house or a customer name, something as such. So here we can see that there's a QR code, and that QR code is unique for each of the programs that have been created for each of the components, right? So the goal here is that we're going to cut stuff on the vertical panel saw. We're going to label the components, and then with this label, these items will go into a cart and a slot. And then that QR code can simply be scanned at the HolzHer CNC machine in order to automatically load that program onto the machine, right? So I'm just opening the program manually at this point. So we can see an example of one of the wall end panels that we've created. So we can see we have our dowels, our dado construction, the shelf line boring, etc. And all of that machining is user definable. So if that doesn't match the specifics of how you create your products, then we can manipulate the templates so that it matches perfectly with your product. We're going to open the cart slot document. So after we cut the components on the vertical panel saw, the goal here would be to cart them so that each component is in the cart in a specific slot that's assigned to a specific order, and now we have a visual reference as to which components are clearly defined and available, right? So what we'll see is in the cart slot document, each of the components for the order has been assigned. So we've got our order number, we've got when the order was created, we have a unique cart identification number as well as a barcode. And then we can see each of the components here has a specific slot assigned, and we have the information available to us if we need to manually remake this product. Now that we have the documentation and the visual aid that defines which cart and which slot each of the components go into, we can take it one step further with something we call Cadet, right? So Cadet is our little soldier on the floor tracking production and ensuring that rework gets completed in a timely fashion, right? So what's going to happen here is that we're going to have Cadet. It's going to have the carting and rework section that we're mostly concerned about. So we can go ahead and open the carting section and type in the cart ID number, right? Or we can simply scan the barcode on the cart slot document, and that will automatically trigger the setup of that cart and tracking it through production. Along with tracking production, what we just saw was rework processed through Cadet. So what we did was entered the hop file into Cadet. Now we've come to EnVision, we see that same hop file, and we simply reprocess that. It automatically creates the cut list and sends it back out to the floor. Now when we go back to Cadet, we can see the status of that specific job. We can see it was sent back to the floor. And now in this section, we'll just enter the cart ID number, and it'll show us the station. So I just have Josh, Noel, and Nathan as the stations. And we can see the last station it was scanned at when it started production. So that's the first time it was scanned, right? And now we can start tracking our rework and our carts and parts through production. Okay, now that we've seen the data that gets created with EnVision, we've seen Cadet and tracking rework as well as the carts and slots through production. Now we can take a look at how we get all of that machining data and bill of materials data. So we'll go ahead and open the template. So everything that we do here is in Excel. So we can take a look at the Excel sheet. There are always 3 sheets inside of the workbook. So the first thing we do is define the attributes of the product. Right? So these are completely user definable. You can have more or less, just depends on how your product is defined and what attributes of the product you allow your customer to change when they're ordering from you. And then each of those attributes has a default value. Now we can simply come into the bill of materials sheet, and what we'll see here is at the top we have basically our global math, right? So any logic or formulas that we're going to use over and over again throughout the sheet, we will do once at the top, and this allows us to change them quickly if anything in the bill of materials would change. Then all of the machining and instructions below that will reflect the new changes that we've made at the top. Now, I know it looks like there's a lot here, but let's break it down into its simplest components. The first thing we see is the MDF door. So in this case, this wall cabinet is also ordering the door. So I know the dimensions of the door itself. I know the quantity of doors per assembly. I know the different materials, the thickness, etc. So now that I've defined the component for the bill of materials, the next thing I'm going to do is define the CNC machining for it. So first, what we do is use the border instruction to define the size of the component for the CNC. Next, we just simply define the machining instructions associated with this specific component. So in the case of an MDF door, we're going to be creating a shaker style MDF door. We have our start line, so where the router is starting the route. And then we have our line instructions, and these are each of the points the router is traveling to. The next thing we do here is our pocket. So basically we're creating the inside angled profile on the shaker door. Next, we're pocketing the center out. And then finally, we have the nested border route, which would cut out that piece from the sheet. Now, in this case, if we're going to cut the component on a vertical panel saw and then simply go to the evolution, we wouldn't need the nested border route unless we needed to put an outside perimeter, maybe a chamfer or some radius on that outside edge. And then next, we're just defining the rest of the component. So I have my right end panel, my left end panel, my bottoms, my tops, my backs, and my stretchers. Now in this case, some of these components get minimal machining, right? So for instance, what we can do is, let's say that we need to do a horizontal boring on the stretchers. So what I can do is copy this instruction and place it down here. Now I'm going to drill a hole, so I'm going to specify the edge that I want to drill on. So I'm going to say the left or the right. And then I'm simply defining the X and Y location on the left face. How deep am I going, and what diameter of bit am I using to bore this hole? Right, and that's it. So now if I needed 4 holes, I can simply rinse and repeat and place 3 more boring instructions, 2 on the left, 2 on the right, and then again just defining their appropriate location on the component. Now when I come in to look at this component and order it, we'll notice that there will now be horizontal boring on it. Right? With EnVision, we walk you through some sample templates that we provide. and then we will walk you through creating a template specific to your product with your attributes, right? Your line boring specific to shelves, if you're using dowels or screws, maybe fasten link or lock dowel, and we will walk through the creation of a template and show you how to utilize the tools in EnVision. Now, the cool thing here is that everything you can do inside of EnVision can be done from what we call the Toolbox. So if I just select the Toolbox and move it over here, I can see I have parts, so I can do some Excel. So I can insert rows, I can delete rows, etc. I have drilling instructions, so I simply select the drill and it adds the drilling command into the template. I have line boring in X, Y, pocket holes, all of my routing instructions, lines, arcs. We have lockdown and fasten link instructions natively built in, so you don't need to do all of the complex machining. You're just defining what edge the slot will be coming from and the final location of the component, pocketing instructions, etc. Right? So anything that you can do with the machine we have available here in the EnVision Toolbox to add these instructions into the template. Now on each of the lines we'll also notice that there are comments. So when I enter data here, I know later that this is position X and this is position Y for this line routing instruction.